Okay, good morning, good afternoon, good evening, whenever you're watching this. This should be Honors Geometry. This should be Tuesday the 21st. And hopefully you enjoyed that little lottery problem yesterday, made you think a little bit. And I don't know, I haven't looked at the choices that were made yet, but I will. Hopefully you chose that second choice. It ended up being a lot more money. You saw that in the last day alone with that second choice, you made more money, or you were paid more money than the other option in total. And on the day before, on the 29th of April, you were actually almost made as much money as the other day in total. So those are examples. That second option is an example of a geometric sequence, which is what we're going to start to look at a little bit deeper this week. And a geometric sequence is when you multiply or divide to get your next term. Remember, with an arithmetic sequence, we were adding or subtracting. Okay. So what the difference here is simply when you add and subtract, you can get big, and your numbers can get bigger as you go, and your numbers can get smaller as you go, but they won't do it as fast, or they won't get as big or as small as if you multiply or divide as you go. Okay, so we're going to explore this geometric sequences a little bit here today. In this first example, we take a quick look at it and first figure out what are you doing to go from one term to the next. All right, not a whole lot to discover there. You're multiplying by 2. Okay, so if we continue that out and we multiply by 2, we get 96. Multiply by 2, we get 192. Multiply by 2, we get 384. And we're going to stop there, but just remember it keeps on going. Okay, you could keep on going as far as it needs to go, and we would just simply keep multiplying by 2. Now, in arithmetic sequences, that number that you added or subtracted, again, was called the common difference. And it was called a difference because if you take any number in line and subtract the number in front, you get that D value. Okay, now with a geometric sequence, this number we are multiplying or dividing by is called the common ratio. And the easy way to get it, or the foolproof way to get it, is to take any number in line and divide it by the number in front of it. So in our case, we could take 6 and divide by 3, or we could take 12 divided by 6, or 24 divided by 12. You get the idea. You could do any number divided by the number in front of it, and every one of these answers is the same. It's 2, that's the number we multiply by. Okay, so that's called the common ratio. And dividing any term by what's in front of it is the foolproof way to figure out what it is. Just like with the arithmetic, the foolproof way to figure out what your D value is to subtract any number minus the number in front of it. Okay, now let me get rid of some stuff here. Clear out a little bit of room. Now we know from last week that, and I'm also going to get rid of these times twos. We know from last week that each of these numbers falls into a position in line. So we call that 3 the first term, that's 6 the second term, 12 is the third term, 24 is the fourth, 48 is the fifth, and then what we do, 96 was the sixth. I'm going to list them all out here, 7th and 8th, okay? They fall into a certain position in our list. But it's important for you to realize, again, what the relationship is between the position in list and how many of these, in this case, these 2's we multiplied by. So to get to the second number line, we would only multiply by 1, 2. To get to the third number line, we would have to multiply by 2 2's. Now again, to get to the third number line, we're going to say we start at the first number. So starting at 3, how do we get to 12? You multiply by 2 twice. And if we go out here a little ways, like this 96 was the 6th term. Well, let's count how many 2's we multiplied by. 1, 2, 3, 4. We multiplied by 2 5 times to get to the 6th number. Well, how many times will we multiply by 2 to get to the 8th number in our list, the 8th term? You would multiply by 2 7 times. So it's important to understand that relationship, that the number of times you multiply, and this was the same as last week with what we added or subtracted, it's always 1 less than the position. All right, and your position we call a sub n. So let's say we know this list continues on. Let's say we want to find this mystery number way out here so far. We don't even know the position. It's a sub n. How would we get there? That's what we want to realize, or we want to be able to determine is how would we get there? Well, we would say to ourselves, and I didn't give myself enough room here, so we would say, how do we get to the nth term? In this list, we would start at 3, the first number line, and then what did we do? We started multiplying by 2. Well, remember, if you multiply by 2 3 times, you don't write 2 times 2 times 2, you write 2 cubed, and so on. So we would multiply by 2 n minus 1 times, and this becomes our nth term rule for this sequence, okay? This geometric sequence, and that's what we want to be able to do today. On your homework, you're going to have to be able to find the next 3 terms, and you're going to have to be able to write the nth term rule for that specific sequence. And this slide's getting a little cluttered up, but there you go. Now, one thing that can happen with a geometric sequence that couldn't happen with an arithmetic is this. This is the exact same sequence, except you see the second term is -6. Well, let's just simply stop right there. What would that r value be? That's what we call the common ratio, is our r value. Our r value would be -6 divided by 3, which is -2. Now remember, you should be able to take any number in our list and divide it by the number in front and get -2. Well, if we take 48 divided by -24, we get -2. If I take 12 divided by -6, I get -2. So we multiply by a negative number here, and that's what makes our sequence alternate. This can't happen with an arithmetic. Okay? So we multiply by a -2 and we get -6. Then you multiply by a -2 and you're doing negative times negative, you get +12. And then you multiply by -2, you're back to a negative. Multiply by -2, you're back to a positive. So the next term would be a -96. Then we multiply by -2 again. Negative times negative is positive. We get +192. Then we multiply by a -2 and we get -384. So for this list, we would say, what kind of a rule could we write that would get us to any number in this list way out here, whatever it might be? We would say we start at 3, but this time we multiply by -2s. And again, how many -2s we multiply by? 1 less than what our position is in line is. Okay, so this -384 right here. We could say, how do we get to -384? How did we get to it? Well, we started at 3. We started at the first spot in line. And then we started multiplying by -2s. And if we count up how many -2s, 1, 2, 3, 4, there's 1 here, 5, 6, 7. Well, it was the 8th position is where this -384 is. It's the 8th position. So to get 7, we just subtract 1. And if we do 3 times -2 to the 7th power, what is 2 to the 7th power? 128. So it's 3 times -128, because it'd be an odd number of negatives. You get -384. So the rule for this sequence is 3 times -2 to the n minus 1 power. Now, another thing that can happen in arithmetic sequences is they get smaller as we go. Okay, so now what you would say to yourself is, here was, how do I go from a 12 to a 10? Well, you divide by 2. Does that happen to go from 10 to 5? Do I divide by 2? Yes, and we keep, you might say to yourself, you're dividing by 2 the whole way out. But remember our rule for finding r, our common difference. We take any number in line divided by the number in front. And when we do that, we get 1/2. So remember this, that dividing by 2 is the same as multiplying by 1/2. And for our value purposes, we have to consider it as a multiplication. So when you see divide by 2, think multiply by 1/2. If we were dividing by 5, think multiplying by 1/5. Okay? And if we continue to go on here, let's erase it a little bit here. Let's fill out our next 3 terms before we get too far ahead of ourselves. So the next term in line would be 5/4 divided by 2, which is the same as multiplying by half. That would be 5/8. And then 5/8 divided by 2 multiplied by half is 5/16. And then it would be 5/32. Now again, whatever term we're going to, if we're going to the second term, we would only divide or multiply by half one time. To get to the third term, we would multiply by half 2 times. It's still one less. Okay? So what kind of a rule could we write to get to this nth term? You might already be a step ahead of me here. What would this rule be for this sequence? You know, it's like directions. How do you get somewhere in this scenario? Well, you start at 20 and you start multiplying by a half. How many times do you multiply by that half? N minus 1 times. So if I'm going to the 35th spot in line, I can tell you this. I know exactly how many 1/2s I would multiply by. I would multiply by 34. Okay? Then if it's getting smaller, so we're dividing, but it's also alternating, well, what's our R value? Well, we could do -10 divided by 20. We could do 5 divided by -10. Again, it's any number in line divided by the number in front. Even these fractions, if we do -5/2 divided by 5, we will get -1/2. So again, we get the same answers, only they're alternating. So what's 5/4 times -1/2? -5/8. What's -5/8 times a -1/2? Positive 5/16. And then it would be -5/32. Whoops, -5/32. So we see a positive, negative, positive, negative, positive, negative all the way across there. But again, what's our rule? See if you can't write this one on your own. Maybe you already are. Maybe you are a step ahead of me. Don't know what's going on there. We would say, how do I get to any number in this list? Oh, well, I got to start at 20, and then I got to start multiplying by -1/2. How many of them will I multiply by? Whatever this position is, -1. And that's what you'll have to do on your homework, is find the next 3 terms and write the rule. Okay? Now, let's talk about generically, if we have any geometric sequence, what's a generic rule for finding a future term, a number that's out there in the list somewhere? No matter what your list is, you always have to start at the first number in the list. So we always start at a(1). Then you start multiplying by something, and we call that the common ratio, R. Then how many of those R's do you multiply by? N minus 1 of them. So that is our nth term rule for geometric sequences, and we'll look a little bit deeper at that tomorrow. Okay? So, but that is your nth term rule for geometric sequences. If you remember from last week, for arithmetic, it was you started at the first term and you started adding some D values, and you added N minus 1 of those D values. So this was for arithmetic sequences. Okay? So for today, here's your homework. Fill in those 3 terms for each of them. Fill in the 3 terms and write your rule. Okay? You can copy it on your own paper, or my kids all have it attached. Also, you can print it out. And don't forget to attach your picture. Okay? Have a good day. See you tomorrow.